On this problem, it says that water is flowing into a tank over a 24-hour period. The rate at which it's flowing is measured at various times, and the results are given in the table. The tank contains 150 gallons when time is 0. And the first thing is to estimate the number of gallons of water in the tank at the end of 24 hours by using a, say, midpoint Riemann sum with 3 subintervals and values from the table. Show the computations that lead to your answer. So the first thing that you want to do is, let's go ahead. This is a technicality thing, but you can get points for this. We know that we're going to have 150 gallons to start with. So it's going to be 150 gallons plus from time 0 to 24 hours of whatever R of t is. So you want to be sure and you put that in before you start doing your calculations. All right, because that's what we're doing. We're finding a midpoint Riemann sum, and it tells us 3 subintervals. So if we go back and we look at our table, and we divide it into 3 subintervals, we're going to have this subinterval, and this subinterval, right?
Yes.
So the midpoint of the first interval is when time is 4. The midpoint of the second interval is when time is 12, and then when time is 20. Now, the width of each subinterval is, the first one is 8 minus 0. Let's see, well, the width is just 8 hours for here. The width here from 8 to 16 is 8 hours, and the width from 16 to 24 is 8 hours. So our dx is 8. So to show the computation, in addition to this, this is going to be equal to approximately 150 plus 8 times R at 4 plus 8 times R at 12 plus 8 times R at 20. Now, if you want to put your 8 in the front to distribute, you can do that too. You can put 8 times in parentheses R4, R12 plus R20. And it's a good idea to put your, before you actually plug in values, it's a good idea to put your R4, R12, R20, because sometimes it's easy to pick up the wrong value from the table, but this shows that at least you knew which value you were supposed to get. You knew the time that you were supposed to get it. So this is 150 plus 8 times 8.8 plus 9.2 plus 8.1. And if you had to do this without a calculator, those numbers are simple enough you could, but you can go ahead and plug that in your calculator if you want to. Notice when it says show the computations, you need to at least have this. Okay, so how many gallons is that at the end of 24 hours in the tank?
358.8.
358.8 gallons. Be sure you put what it is. And if you want to put gallons of water, that's not going to be bad either. All right, so this is asking us the number of gallons of water in the tank. If it asks for the number of gallons added, you wouldn't have to add the 150. But since we started out with 150 gallons, you have to include that. Right. Any questions on that one? So midpoint Riemann sum, not bad. The next one asks us to do what? A trapezoidal sum. Now remember, a trapezoid could look like this. And that's going to give us even a midpoint is going to give us a more accurate approximation than a left hand or right hand. But a trapezoidal sum is even a better approximation than a midpoint. And when we find the area of a trapezoid, it's the width times half the sum of the bases, or in this case, the heights. So if we do a trapezoidal sum, and again, this time it says 3 subintervals. So let me move this. How much is the width of each subinterval still?
8.
It's still 8, but we're going to have our 150, again, plus from 0 to 24. So this is approximately 150 plus 8 times 1/2, half the base times the sum of the heights, right? Because does that make sense? All right, and so we're going to have r at 0 plus r at 8. In this case, I'm just going to go ahead and put 8 plus 9.3. That's the first trapezoid. Plus 9.3. Oops. Plus 8.9.
Where's the 4 on the outside coming from?
Okay, it's each subinterval is 8, but it's half of that. Plus 8.9 plus 6.7. So here we take this and this and this and, wait a minute, not that one. We have to do this one twice. And this one we'll have twice. So we get here approximately
$354.4
okay.
gallons.
All right. So really not difficult to do. You just have to know the difference between the midpoint. Riemann, a Riemann's a rectangle. You could have a left Riemann sum, a right Riemann sum, or a midpoint. And if you need to sketch that, just a few of the rectangles to figure it out, then do that. All right, now let's look at C. I think I'm through with the table. It says a model for this function is given by, and they give us W of t. Use the model to find the number of gallons at the end of 24 hours. Again, at the end of 24 hours means we have to include the 150. So this time we've got 150 plus the integral from 0 to 24. And since they have defined WT, we can just do this instead of writing it out. Now, if this is, you could probably do this one without a calculator, but for time's sake, go ahead and plug this into Y1 and let your calculator find the answer. Okay, approximately 357.36 gallons. Make sure everybody gets that. I want to be sure you are getting it in your calculator.
I didn't get that.
It says use the model to find the average rate of water over the 24-hour period.
Well,
The average rate of water flow over 24-hour period. Are we concerned with how much water is in the tank at the beginning?
no.
No, because we just want the average rate of flow. So how are we going to do that?
Would it be 1 over b minus a times the integral from a to b
Mm-hmm. 1/24 from 0 to 24 of WT dt. So really, you could go back to your previous answer, subtract 150 from it, and then divide by 24, for time's sake. I mean, if this were an AP question, you know you just found it. Just subtract your 150 and then divide by 24. So what's the average water flow rate?
8.64 gallons.
8.64 gallons per hour. All right.